Okay, I'm going over some sections from the Unit 3 Bonding Quiz 3 practice test, and we are going to learn how to draw covalent bonds. So the first step in that is figuring out how many single electrons an atom has available for bonding. And so that goes back to those Lewis dot structures. So here in number 7, we're going to look at each atom, look at the tall group column number, and figure out what the Lewis dot is for that atom. So here I'm looking at chlorine. That is in column number 7, one from the last column there. I'm going to put a 7 above that. I didn't label this periodic table, so let me go ahead and do that now. Okay. All right, tall group column numbers, got it. So we're going back to that chlorine then, here in column 7. That's going to get 7 dots because it's in the 7th column. When we add in the electrons, the valence electrons, those are just the electrons in the outer shell, we put 1 dot on each side till we get past 4. Then we start to double them. So since chlorine has 7, I'm going to keep adding in till I have a structure that looks like this. I have 1 single electron, so this atom can make 1 bond. Now, carbon, 4th group, tall column right here, is going to get 4 single electrons, okay? Because we go 1, 2, 3, 4, because it's in the 4th column, and now we're out of electrons. So we have 4 single electrons, and that's why carbon is so great at making living things, because it can form lots of bonds, and it's going to make 4 bonds every time. Next, we're moving on to iodine. Iodine is here. It's one of the halogens in the 7th column, and so it is going to get 7 valence electrons. I'm drawing those in. 1, 2, 3, 4, 5, 6, and 7. So I have 3 pairs and 1 single electron. That means iodine is making 1 bond. Next one is nitrogen. Nitrogen is a fun one. Makes me think of green because it's in plants. And so there's nitrogen in the 5th column. And so I'm going to do 1, 2, 3, 4, but now since I have 1 more electron, number 5 gets to be paired, just like that. I have 3 single electrons, and I'm going to write the number 3 because that's the number of bonds that nitrogen can form. Oxygen right here. So oxygen is in the 6th column, 6 valence electrons for oxygen. I'm going to draw those in. 1, 2, 3, 4, and then 5 and 6. So I have 2 single electrons left. That is 2 bonds for every oxygen atom. And last one we're looking at is hydrogen. You'll get super familiar with that one. Over here, the only nonmetal on the left side gets 1 electron in its valence shell because it's in the 1st column. And so it can make 1 bond. Interesting, so can chlorine. So it's the number of single electrons that determine the number of bonds. Okay, next step then is we're going to add in what we call lone pairs to the structures that I have already drawn here. So a lone pair is any of what we call these non-bonding pairs, okay? A pair is 2. Now, single electrons participate in the bonds, so they turn into these lines that join the atoms together, and we'll talk more about that. But basically, a carbon atom would give 1 electron, and a hydrogen atom would give 1 electron, and it would create a bond. And that is what covalent bonding is those shared electrons. Now, the pairs that are already on the atoms, they don't participate in the bonding. So hydrogen, shown here, has no pairs. It will never have any more electrons drawn on it, and we don't actually have to show these bonding electrons, the single ones. So hydrogens you just leave alone. Carbon is going to use all its electrons in bonding, so we don't have to add anything else to carbon. But nitrogen, if you look up here, it makes its 3 bonds, its 3 single electrons. It has that, 1, 2, and 3, but it also has what we call 1 lone pair. So I'm going to circle that. That's a lone pair. And we have to put that on any structure that has nitrogen in it. So you can draw it anywhere on the structure or on the atom in the structure. And so I'm just putting that non-bonding pair right there on nitrogen, and my structure is complete. Now I go over to oxygen. I look up here at my oxygen atom, it has 2 lone pairs on it, right? So these oxygens have already made their bonds, but they need the lone pairs added in. Every oxygen will always have the 2 lone pairs. You can draw them in different ways. Actually, really the correct way to do it would be like this, since the molecule is bent in the opposite direction. And when you have an atom with 2 lone pairs as your central atom, in any part of the structure, it's going to produce a bend like that. So I'm going to correct it here. That would actually go like right there, like that. That would be the correct way to do it. Okay, I wouldn't count you off for that though. Just giving you information because we're starting to learn about shape. Okay, so here we have another molecule that I forget the name of right now. And so we have oxygen, nitrogen, and chlorine, though. That's the important thing. We're going to add in our lone pairs for each of those. For oxygen, it's going to be the 2 lone pairs. For nitrogen, it's going to be the 1 lone pair. And for chlorine, we have to add in 3. You look at chlorine here, same for all of the halogens. Fluorine, chlorine, bromine, and iodine. So I'm going to put in my 3 lone pairs, 1, 2, and 3, and now my structure is complete for that one. Okay, so that is your foundation for drawing covalent molecules, and in my next video I'm going to show you how to do that. So thanks for tuning in, and see you in class.